So yesterday in our books we were using scale to find area. Today in session 4 we are using scale to redraw scale drawings. We're going to change our scale and do the drawing again. So here is your try it, the recreation center. Here's the pool. And I just want you to read the directions to yourself and see if you can figure it out without me teaching you how to figure it out. And if you can, super awesome. You can do it however you want to do it, but here's your try it section. Fill that out. Go ahead and pause and unpause when you are done with that. Okay, so hopefully you finished that part, because now I'm going to show you how the book wants to do it. And the book wants to do it with a number line. So we've got this pool, and the original ratio was, the original scale I should say, was 6 meters is 1 centimeter, and they had 2, whoops, not the highlighter, 2.5 centimeters down here, and the pool is double the length, so 5 centimeters up there. And they made that, so let's see, we had to do times 6 to get 15, times 6 to get 30, so this was actually, it's actually 30 by 15. So get out of here, you're old and useless now. 30 by 15. Now, they use their number line down here, but now they want a ratio of 5 to 1. So we've got 5 to 1, and what's we got? So we're going to, if this is actually 15 now, and the scale factor is 5, and we're going smaller than we're dividing. So we have to divide 15 by our scale factor. That'll give us 3. And divide 30 by our scale factor, which will give us 6. So there's our new one right there. Remember, when we're going from the bigger to the smaller, we're going to divide. Okay, let's see. Let's do a little analysis here. You can reason about how the scales in each drawing are related. The original drawing scale, so the first one up at the top, the actual drawing in the recreation center was, the ratio is, it was 6 to 1. I mean, they said that in the problem. And the new is 5 to 1. So the scale, oh, how they relate to each other. That's clever. So the scale from the original drawing to the new drawing is 6 centimeters to 5 centimeters. Because it's 6 to 1 to 5 to 1. There's the original scale, and there's the new scale. But I mean, since it's fractions, you don't need the bottom. So it's 6 to 5, the ratio to each other. Okay, I've used the problem from the previous page to help you understand how to reproduce a scale drawing using a different scale. So what are the dimensions in the new drawing? Well, let's see. We already have the line up here, might as well look at it. It was 3 to 6, 3 by 6. The dimensions were, that's a terrible rectangle. That's the worst rectangle I ever saw. Well, I guess it's just the wrong way. 3 to 6. There you go. How are the two double number lines related? Well, I would say, I'm going to get my typing tool out because I don't want to type, I don't want to write all this. I would say the first one takes you from the original drawing to the actual pool. First number line gets you from the original drawing to the actual pool, and then the second takes you from the pool to the new scale drawing. That'll do. In fact, I like that so much. You get the smiley face. Okay. So looking at the analyze it, it says look at the analyze it. Okay. We're at 6 to 5. How did the dimensions of the pool in the original drawing compare to those in the new drawing? Okay. So, oops, I'll just use my typing tool again. Why not? For every 5 centimeters of 5 centimeters in the original drawing, there are 6 centimeters in the new drawing. Because if you recall, the ratio is 6 in the original drawing. No, 6 in the new drawing to 5 in the original. New, original. Okay. The new drawing is a scale drawing of both the actual pool and the original drawing. Why? Well, the ratios remain the same. Oops. Or equivalent. I'm going to say equivalent. That's better. Remain equivalent. But the sizes are not the same. They're different. But the sizes are different. There you go. So that makes them, I mean, the ratios are the same, but the sizes are different. That's the definition of a scale drawing, right? Okay, and then we're going to reflect before we hit our next apply it. So think about all the models and strategies you've discussed today. Describe how one of them helped you better understand how to solve the triad problem. So what, just basically right here, just tell me what out of what we went over helped you understand what we were doing. Go ahead and pause and answer that now. Okay, so you've unpaused and we're on to the next thing. Use what you've learned to solve these problems. So here's a few practice problems for you, and then there's going to, with me, and then there'll be some practice problems on your own after that. So each one of these represents 8 feet. So this is 16. This is 5. This is, let's see, 8 times 5. That's 40 feet. 8 times 4 is 32 feet. 8 times 3 is 24 feet. 8 times 2, that's 16, and 16. Okay, so now it's going to take twice as much to represent that. So now it's 4 feet is every 1 centimeter. So let's do 32 now. Let's see, we need to get 32, but each of these is 4. So we're going to take 8 of these now. 1, 2, 3, 4, 5, 6, 7, 8. Did I count those right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I went too far. There we go. And we're going to have to double this. So this is going to be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how we doubled. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then we can connect that there. There we go. So the opposite of what I said before. Let's see. Okay, so we're doing it, let's see, since now it takes 2 squares to represent 8 feet. All the lengths will have to be doubled. There we go, that's better. Okay, so same deal down here now. We're going to, let's go to the original and then go to the new one. So we're not taking any shortcuts here. Okay, so the scale factor for the original drawing is 8. So if we multiply this by 8, we've got 24 feet by 24 feet. And now this is 12, the new one is going to be 12 to 1. And we're going to make that 12 feet, and we've got 24 feet. That's going to be 2. There we go, that's pretty easy. I'm going to change my color over here. So the new drawing is going to be 2 centimeters by 2 centimeters. Now, so go to the original drawing first. It's a little easier that way, I think. And our last one here, a design for a playground includes a sandbox. The length of a square on the grid is 1 inch, or represents 1 inch. The scale from the playground drawing is 12 inches to 1 inch. Let's highlight that. 12 inches to 1 inch. So draw another scale drawing of the sandbox using a scale from the playground. The new drawing is 20 to 1, so we're going to change to 20 to 1, and then we're going to justify why it's accurate. So let's go ahead and just say we're multiplying by a scale factor of 12. So 12 times 1, 2, 3, 4, 5. That's 60. So this is 60 by 60. Now our scale factor is 20, but we're going small, so now we're dividing. So this one is going to be, let's see, 60 divided by 3, or 60 divided by 20 is 3. So this one's just going to be 3 by 3. There we go. So there's the new one, and now we've got to justify why it's accurate. Let's see, let's think about this. I'm going to use my typing tool again. So the scale factor for the original drawing is 12, and you're getting bigger, so you multiply. The scale factor for the new drawing is 20. And you're getting smaller, so you divide. There you go. Oh, and one thing, now if you remember from your apply it above, the ratio from the old drawing to the new drawing is 12 to 20. Which, if you remember how to reduce fractions, we can reduce both of these by 4. So the ratio of the old drawing to the new drawing, or I should say the new drawing to the old drawing, is 3 to 4. So 3 here, notice there's 3 here. Nope, sorry, 5. See? Getting tired. 5, 3 to 5. So that pans out. There you go. Alright, now your turn to do some practice. And remember, go from the original scale drawing to the full-size figure, then to the new scale drawing. So you're going to do pages 25 and 26. And you're going to take a picture of those, and you're going to upload them to Canvas. And you're going to message me if you need anything. And you're going to check your Whirlpool to see if you need any other work to do. And good luck.